All right, so here are the notes from lesson 1, but part 2. So this is day 2 of lesson 1. Still on the front page of your notes packet. We'll cover electrolytes and non-electrolytes. So electrolytes you've probably heard of from Gatorade and other sports drinks. Electrolytes are something your body needs so your muscles don't cramp up. You need enough salt and potassium or different salts in your body for your muscles to work properly. So if you do, especially a lot of activities or high endurance activities, it's important that you maintain a good electrolyte balance for your muscles to properly work and perform. So an electrolyte is a compound that conducts an electric current when it's either in solution or when it's melted. So an electrolyte is going to have these positive and negative charged particles. So anytime a substance dissolves and has those positive and negative charges, it will be an electrolyte. A non-electrolyte is a compound that will not conduct electricity or not conduct a current because it doesn't break up into ions. So the molecules that stay together as a whole molecule are going to be non-electrolytes because they are not going to conduct a current. All right, so here's a quick check-in. So this kind of ties the information from yesterday and today all together. So from yesterday, ionic or covalent. Remember, ionic is a metal and a nonmetal. Covalent is two or more nonmetals. So you have to look on the periodic table to figure out if it's ionic or covalent. So take a second, pause the video, go through each example and see if you can classify each one before you check your answers. And then we'll do the green box about electrolytes and non-electrolytes. All right, so hopefully you've paused the video and taken time to try these on your own because that's how we learn best, is to try them and apply the information on our own before we check our answers. So KBr is a metal and a nonmetal, so that is ionic. AlCl3 is a metal and a nonmetal. NH3 is two or more nonmetals, so remember hydrogen, even though it's on the left of the periodic table, is a nonmetal, so that's covalent. MgCO3, this is a metal and a polyatomic ion, so it's going to be ionic. SO2 is two or more nonmetals, so it's going to be covalent. C12H22O11 is also covalent. HCl is kind of an exception. HCl is covalent, however, it is an acid, so it behaves differently. So I'll explain it in the notes. You won't be asked to know this for a test or a quiz, but it is covalent, but it does behave a little differently than the others. So BaSO4 is a metal and a nonmetal, so it's going to be ionic. All right, so then for electrolytes or non-electrolytes, so remember, if you have an ionic substance, that's going to break apart into positive and negative ions. If you have a covalent compound, that molecule, stays together and does not break apart. Oops, my pen is not working very well. So that molecule stays together. So if you have an ionic substance like KBr, that is going to break apart into positive and negative ions, which means it will be an electrolyte. AlCl3 is also ionic, which means that it is going to break apart into ions and be an electrolyte. NH3 is covalent, which means it's not going to break apart. The molecule is going to stay together. When the molecule stays together, it is going to be a non-electrolyte. MgCO3 is ionic, which means it's going to break up into ions and be classified as an electrolyte. SO2 is covalent, which means the molecule is going to stay together, so it's going to be a non-electrolyte. C12H22O11 is covalent, so it's going to stay together and be, a non-electrolyte. HCl, like we said, is covalent. HCl is actually an acid, so anytime the substance starts with hydrogen, it is usually an acid, or that's one of the definitions. So we'll learn about acids by the end of the year, but this is actually an electrolyte. So like I said, it is an exception to the rule. You won't have to know that for this test or quiz, but we will mention it later on. And last but not least, BaSO4 is ionic, which means it is going to be an electrolyte. All right, the last terms for the notes today are strong versus weak. So strong electrolytes means that every single molecule breaks apart into the positive and negative ions. So dissociate means to break apart. So if every single molecule breaks apart, you're going to have more H plus ions and more Cl minus ions in solution, which means it's going to conduct a stronger current, which means it's going to be a strong electrolyte. A weak electrolyte only partially breaks apart. So when you have this, which is vinegar, by the way, so vinegar is a weak electrolyte. So some of the molecules break apart, but some of them are going to stay together, which is why you have this double arrow, because you're going to have some of this main substance in the solution, but you're also going to have some positive and negative charges. You're just not going to have as many positive and negative charges, so it's going to conduct a weaker current, which means that is a weak electrolyte. All right, so we'll do a lot more practice in your digital notebook, but of course, as always, make sure you ask questions when you have them.